Hello, 1 2 1 2. Okay, I think the audio is working now, so we can proceed. Yeah, hi everyone, welcome back to the Bioinformatics Coach channel. In today's video, I'm going to show you how you can assemble metagenomic data using Megahits. Yeah, so that's what we are going to do next. So if you want to read more about Megahits, then I suggest you check the GitHub page, the developers GitHub page, and then once you do that, you should be able to get the Megahits documentation. I'll leave the link to that page in the description box. So let me just check here first. Let's show that screen so that you see the GitHub page. I'm trying to set it up now, so I will just give me a moment. Let me set that one up now. So I'll shift to the GitHub page now. By this time, you should be able to see it. Okay, perfect. So there's the GitHub page. So I'll leave the link to this page in the description box so that you can read more about this too. So when you are here, you can scroll down, you'll find some notes about Megahits, how to install, how to use Megahits, etc. So just check this page and then you are going to get more information about it. So that's what we are going to do. So in this tutorial, that's what we will do. These are the activities we are going to perform. Let me shift to the PowerPoint again. I'll shift there. Let's see. So that's what we are going to do. We are first going to install Megahits, and after that, we are going to download the example data. We will use an example data to perform the assembly. After that, we are going to assemble the data, and then we are going to explore the output file. So these are the 4 activities that we are going to do. So if you want to follow this tutorial, then you need to make sure you have a Linux or macOS system. And you should also have Python installed. If you have Anaconda installed, that's fine, but we will not need it in this tutorial. Okay, so once you have Linux or macOS and you have Python, you can install Megahit. For Linux users, you can install the binaries. If you're a macOS user, then you can install using Anaconda or other modes of installation, which are all described or indicated on the GitHub page of Megahit. So that's what we are going to do. So without further ado, let's start the exercise. So I'll go back to this slide. We will start with the installation of Megahit. So let's start. So that means I'll first go to the GitHub page. I'll share that screen now. We are going to the GitHub page for Megahit. So I will do that now. Okay, so on this page, we need to get the binaries. I'm using a Linux system, by the way. So I need to get the binaries. So I'll scroll down to this one here, pre-built binaries. That's what I'm going to use. So there's already a link here that I can use. So I'll just copy this link and then I'll send it to my terminal. But if you want previous releases of Megahit, then you can just come to the releases section here. When you click it, you have access to previous releases as well. So we have source code, we have binaries, etc. So just check. But you should be fine using this one here, the one indicated here, because normally this will be the latest version. So I'll copy it again. Then I'll move to the terminal. That's what I'm going to do now. So let's move to the terminal. Let's check. Okay, so I'm on the terminal now. So what I'll do first is to create a working directory. That's what I'm going to do. So I'm going to say make the metagenomics, and then I'll cd into it. And then I'm going to download the binaries. So I'll say wget, and then I'll supply the download link, which is here. So I'll download the binaries now. Okay, so it's been downloaded now. So let's wait. Download is complete. So let's check the file. So let's do an ls and we are going to find this file here. This is a table file. So that means we need to extract the contents. So I'll say tar svfz and then I'll specify the name. So everything has been extracted. So let's check again. So if you do an ls, you are going to find this directory. This directory has the Megahit binary. So I'll ls into it. I'll see this. So the files can be found in the bin directory. So I'll just ls and then say bin. And I'm going to find the file there. So this is Megahit, the executable. This is what we are going to use. What I'm going to do now is to rename this directory because it's long. So I'm going to rename it so that we can get a shorter name. So to rename a directory, we use mv. And then I will specify the name. And then I also indicate the new name, which is Megahit. So it has been renamed. So do an ls and we are going to find it there. And by the way, if you are new to the Linux environment, then I'll suggest you watch my video on managing directories. Okay, so this is a tutorial I made for beginners, those who are starting to learn Linux. So it shows you how to create, how to rename, how to remove files, etc. So just check the description below, you'll find the link to that video there. Okay, so now we have renamed it. So we can call Megahit to test. So here you can still do an ls into it, ls into bin, and then you find your files there. Perfect. So now what we are going to do is to test Megahit. I'll just do it here. Let me just do this. Yeah. So what I'm going to do is to test Megahit. So to test Megahit, I'll say Megahit /bin /Megahit. So that will run the Megahit executable for me. Okay, so let's proceed. So when you execute the Megahit binaries, it's likely we are going to find this message here. Okay. So when you execute the Megahit binary, it's likely you are going to find this message here. So I'm using Python. Okay, my environment using Python 3. So I don't have this name, the exact name for Python. I have it as Python 3. So what I'll do is to create a symlink that will link to my Python 3. So this mine is Python 3. I'm using Ubuntu. So I don't have Python itself, I have Python 3. That's version 3. So because Megahit is looking for this name, Python, and it does not find it, that is why it has this error message being displayed for me. So it tells us that it cannot find Python. But of course, there's Python, which is Python 3. So what I'll have to do is to create a symlink, or for Windows users, we will say a shortcut. I'm just using that phrase loosely here. So what I'm going to do is to create a symlink that will link the name called Python to this one here, this original Python 3 file. Okay, so I'll create it. So to create a symlink, you need an admin access. Okay, I have an admin access on my system. So I'll use a sudo command. So I'll say sudo, and then I'll say ln-s, and then I'll indicate the path to my Python 3. So that will be /usr /bin /Python 3. And then I'll also indicate the new name. So that will be /usr /bin /Python. I want it to be in the same directory as this one here. So I'll create a symlink. So to create a symlink, you need an admin access. Okay, so I have already done that first, and that is why I was not asked any password. But if you are using it in your system, it's likely you'll be asked a password. So you just have to make sure you enter a password, and then you'll be fine. But if you are working on a remote server like a computer cluster, then you need to contact your system admin, and then your system admin will configure it for you, or you can just use Anaconda to make things easy for you. So with Anaconda, you don't need any admin access. You just have to install it straight away, and then you can get Megahit installed. And I have 2 tutorials that show how to install Megahit. So I'm going to upload those tutorials on Sunday or Monday, so you can check those videos out to know how to set up Megahit on a Linux system. Okay, so I have done that. So now I'm going to test Megahit. So to test Megahit, I'll say Megahit /bin/Megahit. Perfect. So once I do it that way, then everything will be displayed nicely for me. So once I have this here, that means that Megahit is working fine. So now we have tested it and it's working, so we can proceed. I'll just clear the screen and then continue. So now that we have Megahit working, we have it downloaded and configured, we will have to download the example data. So the example data can be found on the Galaxy page. There's one Galaxy tutorial on metagenomics, so I'm using that particular tutorial. I'll leave the link to that tutorial in the description box. So let's go back to our browser. So this is the page. I'll leave the link to this page in the description box. So this is it. This is the Metagenomics Assembly tutorial. So here, I will encourage you to also read the notes here because it's important you have an idea of metagenomics if you're a beginner. But we are going to download the data, so we will move down. We will scroll down. So when you are here, you can just go to prepare analysis history and then data. So when you click it, this will send you to this particular section here, which has some files here. So in this tutorial, we are going to use this one here, these 2 ones here. These are paired and reads. We will use just one sample, which is this one, but you can try with the other ones too. That is fine. We are just playing around with Megahit, so any of these samples is fine, but I prefer to use this one here. So I will need to download these files. So to download, if you're on the browser, you can just right click and then just click on open link, and then you'll be asked to save it, and then you can save it. But if you are working on a remote server, then it's advisable you copy the links and then download them using a bash script, and that will even be much faster and more convenient. So what I'll do is to get all these links, just these 2 files, because I'm dealing with paired and read. So I'll copy them, and then I'll move to the terminal. So on the terminal, I'll create a bash script. So I'll say nano download data.sh. And then I'll just add my shebang line. And then when I'm here, I'll just paste both links. I'm going to use wget. So I'll just bring wget here. That'll be the first thing to do. And I'll also bring that here to download them. So once I have them, I'll just save changes and exit. So now if I do an ls, I'm going to find my scripts here. So if you want to execute a bash script, you can just type bash and then specify the scripts. But I prefer to use another method. So to do that, I'll need to first add execution right. So I say chmod +x, and then I'll specify the scripts. And then after that, I'll do an ls again just to make sure I have the script. And then I'm going to execute the script to download the files. So I'll say /download data. So this will download the files for me. Okay, so as the files are being downloaded, let's check if we have messages. I'll check if there are messages here that we can read. I think we have some people watching, so I don't know if they've sent messages or not. So I'll just check and then read some messages if they are available. Let's see. Okay, I have 4 people watching. That's okay. Okay, so as it's downloading, I also like to say that I have some other metagenomics tutorials, and so I'll leave the links to those videos in the description box as well. Actually, I'm going to leave the link to the playlist rather, so that you can get access to all the other videos. And also I have another channel called Bioinformatics and Data Science Clips. So for those ones, that will have short clips of the tutorials I make here. So if you are looking for short tutorials where you don't need to go through the entire tutorial here, maybe you are looking for maybe a simple command like maybe sum to sort, or maybe sum tools, let's say BCF tools view, or sum to sort, or maybe a mapping command or something like that. So you can just go to those clips and then watch them, because those ones I just give the command straight away without explaining them. So that one is more like for the impatient users, those who already have the knowledge and just want the command to do their work. Then that channel will be good for them. So go check that out. The link to that channel is also in the description box. And for those who are interested in machine learning stuff, there's also another channel called Data Science Coach, which you can get some Python tutorials just to learn machine learning. So you can check the description box. You'll find the link to that channel as well. And those who want to support on Patreon, you can check the description box. I have my Patreon channel. The link is there. You can go and then support. And also, I always upload a script for the tutorials on Patreon. So you can just be a patron and then you can get access to all the script that I use for my YouTube channel. Perfect. So let's go. Now the files have been downloaded. So let's check them out. So I'll do an ls first to see what I have. So these are the files. I have forward and then reverse. So here the forward is the read 1, the reverse is the read 2. Okay, so we are almost there. I have the files here, but I prefer to organize my files in a certain way. These are FASTQ files. These are the example data. So I'll prefer to place them in a different directory. So I'll say make that FASTQ. And then I'm going to move these files there, the FASTQ files. So I'll say mv star.FASTQ star. Okay. And then I'll move them to FASTQ. So if I do an ls, the files are no longer there. They are in the FASTQ directory. So basically this one here says we should move all files that have this .FASTQ and then have other names as well. So we are basically dealing with these two files, this and then this. So I have them here. So I'll do an ls into FASTQ and I'm going to find them there. Perfect. So now we are ready. We have the files. Okay. We now have our FASTQ files. So what we are going to do next is to assemble this metagenomic data or metagenome data. Okay, we are going to use Megahit. So with Megahit, let me just call Megahit again /bin. Okay, I think I have to do it here. Let me do it here. Megahit /bin /Megahit. This one here. So this is the help command. Okay, so this will give you the usage, the instructions here. So in this tutorial, we are going to call Megahit and we are going to specify some options here. We will use -1 to indicate the forward or the read 1, -2 for the reverse or the read 2. And then we will also indicate these options. So -k-min is used to specify the minimum KMA size. And then we also have -k-max, that's maximum KMA size. And we also have the k-step for increment of KMA size of each iteration. So we are going to specify these options. And then we are also going to indicate the output directory as well as the number of threads. So we are using the command that was used, or the options that were used in the Galileo tutorial. So when you go to the Galileo tutorial, when you go to the Megahit section, which is here, we have 21 for minimum KMA size, maximum KMA size is 91, and the increment of KMA size of each iteration is 12. So we are going to use these options together with the number of threads, the output directory, and then the flags to specify the input files. So let's go back to the terminal. So on the terminal, I'll do this. Let's do an ls into FASTQ. So if you take a look at these files, you will see the names. The names are long. To me, the names are very long. Okay, so when we type on the terminal, it's going to occupy space here, everything here, which sometimes if you're not an advanced user, you may end up maybe changing some of the text and all that. So we are going to assign these names to variables. So let me show you how it's going to be done. So I'll say read1, or you can also use forward or reverse, whatever, but I'll say read1 equals, and I'll say FASTQ / and then I'll give the name. Here will be read1. And then for read2, the same thing, but this time it will be read2, like this. So now if I do an echo $read1, I should get the name, which is here. Echo $read2, echo $2. I should get this name. So if you do the echo and you get these outputs, then you are fine. We can proceed. So now we are going to assemble the data. So to do that, we'll call Megahit. So Megahit / bin / Megahit. Okay, this is the binary, and then we indicate -1 for forward, and that will be $read1. -2, that will be $read2. And then we also have, let me indicate -t for the number of threads. So if you are using your normal laptop, maybe you are limited in terms of threads, you can use 8, but you need to make sure that you have the 8 cores. Okay, the genome assembly process is computationally expensive, so usually it's advisable to use a high-end PC, or better still, use an HPC cluster where you have lots of RAM and then lots of cores. Okay, so you need to know that if you use -T8, it may probably take you about an hour and a half. Okay, so I tried it. That's what how much or how long it took. So if you're going to use -T8, then it's going to take you probably about an hour and a half. So just take note of that. So if you have more than 8 cores, you can increase it. Maybe you have 30 or 38, but just use 8 if you're using your normal laptop. Or better still, just use an HPC cluster to save you all these inconveniences. So -T has been done. Let's look at the other option. We have -k min. We are going to use 21, and then -k max. We are going to use 91. Then the k step, we are going to use 12. And then we also have to specify an output directory. So that will be -o. And then that will be, let's say, megahit _ results. Okay, so this is the command that we are going to use. Okay, so once you have this command, then you can execute Megahit. So let's execute it now. Okay, perfect. So if you execute it, then you will see this message here telling you that the genome assembly process has been started. Okay, so once it has been started, you can just indicate, or you can just wait. Yeah, so once that has been started, you can wait whilst Megahit does its work. Okay, so that's how it's going to be done. But I have already executed this command on another environment, so I will shift to that one. So if the genome assembly is successful, we are going to get this message here. Let me show you here. This is what we are going to get, because I have already done it. So this is the message that I got after it has been successful. So I will shift here. Okay, so let's proceed. So I'll just clear the screen and check the output files. So the output files will be found here, megahit _ So let's ls into it, and we are going to find the output files there. So these are the output files. So for this tutorial, I am focusing on the final.config.fa. This has the assembled sequences. So because it's a FASTA file, we can even check the number of contigs that were identified by Megahit. So I can just say grep. First of all, let me just do a head first. I'll say Megahit underscore results final.config.fa just to see the file. So these are the sequences. So if I want to count the number of contigs, let me just repeat again. This is a FASTA file. So you have your greater than symbol, you have the names, and then some information here, and then the sequences. So if I want to get the number of contigs or the number of sequences here, then what I have to do is this. Let me just do an ls again. I have to count the number of greater than symbols. Okay, let me just do it again. I have to count the number of this one because a line that begins with this indicates a sequence. So I'll say grep, and then I'll indicate that particular symbol here, and then I'll specify the file, which is here, final.config.fa, and then I'll count them. So I'll just say wc-l. So this will give me the number of contigs identified. So we have 228719. I think it's the same thing that was reported on the Galaxy page. Let's check. When you scroll down, how many contigs are identified for this sample? When you check, it should be the same or almost the same. Okay, this let's check. Okay, I think mine is different, so probably I use a different sample or so. Let's check if I have that number there. Okay, I think I have. Okay, so this is for 68, this is for 72. So 228719. Okay, yeah, I have it here, the same number here. And let's check. Yeah, so I have contigs for this sample. That's what we use. So 228719, and I had the same thing, which is, so that means that particular process or that activity is reproducible, so which is good. So these are the output files. So after you have performed your metagenome assembly, there are a number of things you can do. So you can evaluate and then visualize the assemblies. You can also identify the genome assembled genomes. But in the next tutorial, what I'm going to cover is the evaluation of evaluating the assemblies as well as visualizing the assemblies. So to evaluate the assemblies, you can use tools like MetaQuest, and to visualize, you can use tools like Bandage. You can use those ones to kind of do the visualization, because the evaluation is kind of like a QC to let you know the quality of the assemblies, and then visualization will also help you to know if you even have complete bacterial sequences or not, and also identify occurrences such as long repeats and etc. But I'm going to cover the evaluation and the visualization in another tutorial, so just make sure to come back later to watch that. So let's check the tools that can be used for the evaluation. So we have MetaQuest, which is here. I will leave the link to this page in the description box. We also have Bandage for visualization, which is here. So you can check. I will leave the link to this page also in the description so they can start reading about them. So basically in this tutorial, they performed the quality control where they evaluated assemblies using MetaQuest and also visualize using Bandage. So I'm going to basically reproduce this tutorial, and then I'll let you know what time I will upload. So these are the things we are going to do next. Now let's look at another thing here before we go. Let's take a look at this situation. What we did was to use a single file. Okay, not single file per se. What we did was to use a single sample. So if I do an ls into FASTScale, I have my files here. So there's a single sample. Okay, one sample, because we have read 1, read 2. Now if you have lots of samples, let me just do this. I think it's not this one. Let me just share that one here. It should be somewhere here. Let me check. I should have some FASTQ files here. Yeah, this one here, perfect. Perfect. So if I have a situation like this where I have several samples, then it's going to be cumbersome trying to issue a command such as what we did here. Okay, to issue a command like this for each of the samples. So in that situation, you have to use a script. So I've prepared a script and also a tutorial. Okay, a tutorial on how you can assemble metagenomics data if you are dealing with multiple samples, the strategy you can use, and I also give an example script. So in that script, I show you what to do, how to create your own scripts, and also how to use the scripts that I've written to assemble metagenomics data. So if you have lots of samples, then I will encourage you to watch that video. I'll leave the link to that video in the description. So you can just watch that video, get a script, and you can use that to automatically get all your samples and then assemble them. So that is something that you always have to do. If you also have other samples which you want to assemble and there are issues, you can always book a session with me or contact me and we can work something out. So that'll be all for this tutorial. Let me get your comments. If you have anything which you think can be added, just put in the comment section and then let others also learn. So thanks for watching and I'll see you in the next session.